हेलो बच्चों, इस एपीसोड विच तुसी प्रोबेबिलिटी दी कुछ यूजफुल टर्म्स बारे सीखोगे जो कि हन रैंडम एक्सपेरिमेंट, सैंपल स्पेस, इवेंट, एक्सियोमैटिक अते क्लासिकल अप्रोच टू प्रोबेबिलिटी अते थ्योरम्स ऑन प्रोबेबिलिटी। आओ हुन शुरू करिए।
Let us first try to understand what probability is. Dictionary meaning of probability is likely, though not certain to occur. Probability is a concept which numerically measures the degree of uncertainty and therefore of certainty of the occurrence of an event on a scale of 0 to 1. Its conception is in the study of games of chance. It plays an important role in decision making in day-to-day activities. So we shall discuss some concepts used in probability. First of all, experiment. An operation which can produce some well-defined outcomes is known as an experiment. Random experiment. Any experiment whose outcomes cannot be predicted in advance or determined in advance, like tossing a coin, throwing a die, etc., is a random experiment. Sample space, the set of all possible outcomes in a random experiment, is called a sample space. Like in tossing a coin, there can be two outcomes, head or tail. So the sample space in this experiment is a set consisting of numbers h and t. It is generally denoted by capital S. We define some more terms which are required for defining probability. Event. Every subset of a sample space is called an event. For example, in a single throw of a die, the sample space S is the set having members 1, 2, 3, 4, 5, 6. S, the set containing 2, 4, 6 is a subset of S. So getting the even numbers in throwing a die is an event. Types of events. An event is said to be simple event if it has only one sample point in the sample space. If the event has more than one sample point, then it is called a compound event. The set S is also a subset of itself, so S is also an event. Since every outcome of the experiment is a member of S, the event represented by S is sure to occur whenever an experiment is performed. So the event S is called a sure event. For example, if the event A is getting an even or odd number when a die is rolled, then A is a sure event. Again, the empty set phi is also an element of S, so it is also represents an event. If E is the event of getting a number greater than 6 in the experiment of rolling a die, we see that this event cannot occur, and as such it is an impossible event. Some more events. Mutually exclusive events. Two events A and B are called mutually exclusive if occurrence of an event excludes the occurrence of the other event. That means they cannot occur together. For example, in throwing a die, S is the set having members 1, 2, 3, 4, 5, 6. A is the event of getting a number less than 3, and B is the event getting a number greater than 5. So in a single throw of a die, these two events cannot occur together, so they are mutually exclusive events. Exhaustive events. A set of events is said to be exhaustive if one of them necessarily occur every time the experiment is performed. This means if E1, E2, E3 and so on are the subsets of S, then E1 union E2 union E3 and so on should be equal to S. Equally likely events. Events are said to be equally likely if none of them occurs in preference to others. There are different approaches to probability. Classical approach to probability of an event is calculated using counting techniques. If a random experiment A can result in n equally likely outcomes and m of them are favorable to the happening of the event A, then probability of happening the event A, written as P of A, equal to m divided by n. For example, if we are to find the probability of drawing a king from a well-shuffled pack of 52 cards, since any card can be drawn from 52 cards, so there can be 52 outcomes. Again, as there are only 4 kings, so 4 outcomes are favorable to the happening of the event, and so the required probability is 4 by 52, or we can say 1 by 13. Axiomatic approach builds up the probability theory from a number of assumptions. They are: Axiom 1. Probability is measured along a scale of 0 to 1. That means 0 is less than or equal to P of A, is less than or equal to 1. Axiom 2. Events which are certain to happen, that is P of S, where S is the sample space, have probability 1. Axiom 3. It is related to infinite number of mutually exclusive events A1, A2, A3 and so on. AI intersection AJ is pi for I not equal to J. Probability of happening of either of the events, that is P of A1 union A2 union A3 so on, is equal to P of A1 plus P of A2 plus so on. This approach is useful in developing the theory of probability, but does not tell how to compute the probability of an event. After learning different approaches to the theory of probability and the rule to compute it, let us now learn some theorems on probability dealing with addition and multiplication rules of probability and their applications in the computation of probability of the events. Addition theorem of probability. This states that if A and B are two events of the sample space, then probability that at least one of the events A or B occurs is given by P of A union B is equal to P of A plus P of B minus P of A intersection B, where P of A union B is the probability of occurring either A or B, and P of A intersection B is the probability of occurring both A and B. If A and B are the mutually exclusive events, then P of A union B is equal to P of A plus P of B. Again, as the events A or not A are mutually exclusive and one of them is certain to happen, so P of A plus P of not A is equal to 1. Multiplication theorem of probability states that if A and B are two independent events, then probability of A intersection B, that means both A and B occur, is equal to probability of occurrence of A into probability of occurrence of B.
ਹੁਣ ਤੱਕ ਤੁਸੀਂ ਪ੍ਰੋਬੇਬਿਲਿਟੀ ਦੀਆਂ ਕੁਝ ਯੂਸਫੁਲ ਟਰਮਸ ਬਾਰੇ ਜਾਣਿਆ ਹੈ। ਆਓ ਹੁਣ ਇਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਐਗਜ਼ਾਮਪਲਸ ਨੂੰ ਹੱਲ ਕਰੀਏ।
Now let's see an example. An experiment consists of rolling a die and then tossing a coin once if the number on the die is even. If the number on the die is odd, the coin is tossed twice. Then write the sample space for this experiment. Now its solution. When a die is rolled, then either an odd number appears on the face or an even number appears. if the number is even, that is, it is 2, 4 or 6, then a coin is tossed once, which results in two outcomes, that is, head or tail. Thus, in this case, the possible outcomes are two H, 2T, 4H, 4T, 6H and 6T. Further, if the event of odd number that is 1, 3 or 5 occurs, then the coin is tossed twice, which results in 4 outcomes, that is, head, 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 tail, tail, head and tail, tail. So, the possible outcomes for this event will be one HH, 1 HT, 1 TH and 1 TT, 3 HH, 3 HT, 3 TH and 3 TT and 5 HH, 5 HT, 5 TH and 5 TT. Thus, the sample space of the given experiment is one HH, one HT, one TH, one TT, 2H, 2T, 3HH, 3HT, 3TH, 3TT, 4H, 4T, 5HH, 5HT, 5TH, 5TT, 6H and 6T। ਭਾਵ ਇਸ ਤਰ੍ਹਾਂ ਦਿੱਤੇ ਗਏ ਐਗਜ਼ਾਮਪਲ ਲਈ ਦਿੱਤੇ ਐਕਸਪੈਰੀਮੈਂਟ ਦਾ ਸੈਂਪਲ ਸਪੇਸ ਹੈ 1HH, 1HT, 1TH, 1TT, 2H, 2T, 3HH, 3HT, 3TH, 3TT, 4H, 4T, 5HH, 5HT, 5TH, 5TT, 6H ਅਤੇ 6T ਜੋ ਕਿ ਅਸੀਂ ਪਤਾ ਕਰਨਾ ਸੀ। Now let's see another example. From a group of 2 boys and 3 girls, 2 children are selected at random. Then describe the following events. Event A, when both selected children are girls. Event B, when selected group consists of 1 boy and 1 girl. Now its solution. Event C, when at least 1 boy is selected. Then which of the following? Then which of the pairs of events are mutually exclusive? Now its solution. We know that 2 events are mutually exclusive if they do not have any common members, or symbolically, if their intersection is a null set. Here we are given that a group of 2 boys and 3 girls, that is total 5 children, now 2 children are to be selected out of 5 children. Now if we denote the boys as B1 and B2, and the girls as G1, G2 and G3. Then for the event A, such that both selected children are girls, therefore event A is equal to the set with outcomes as G1, G2, G1, G3 and G2, G3. Now for event B, such that the selected group consists of one boy and one girl, therefore event B is equal to the set containing outcomes as B1 G1, B1 G2, B1 G3, B2 G1, B2 G2 and B2 G3. Now for event C, such that at least one boy is selected, therefore event C is equal to the set containing outcomes as B1 G1, B1 G2, B1 G3, B2 G1, B2 G2, B2 G3 and B1 B2. So here we get set A, set B and set C. So we find that set A and set B do not have any common members. Therefore we can say that A intersection B is a null set. Therefore we can say that set A and B are mutually exclusive so thus event A and B are mutually exclusive events. Similarly, set A and set C do not have any common members, that is A intersection C is a null set. Therefore, we can say that set A and set C are mutually exclusive. Thus, events A and C are mutually exclusive events ਸੋ ਇਸ ਤਰ੍ਹਾਂ ਦਿੱਤੇ ਗਏ ਐਗਜ਼ਾਮਪਲ ਲਈ ਸੈਟ A ਅਤੇ ਸੈਟ B ਮਿਊਚੁਅਲੀ ਐਕਸਕਲੂਸਿਵ ਇਵੈਂਟਸ ਹਨ। ਇਸੇ ਤਰ੍ਹਾਂ ਸੈਟ A ਅਤੇ ਸੈਟ C ਮਿਊਚੁਅਲੀ ਐਕਸਕਲੂਸਿਵ ਇਵੈਂਟਸ ਹਨ ਜੋ ਕਿ ਅਸੀਂ ਪਤਾ ਕਰਨਾ ਸੀ।
ਹੁਣ ਤੱਕ ਤੁਸੀਂ ਪ੍ਰੋਬੇਬਿਲਿਟੀ ਦੀਆਂ ਕੁਝ ਯੂਸਫੁਲ ਟਰਮਸ ਤੇ ਆਧਾਰਿਤ ਕੁਝ ਐਗਜ਼ਾਮਪਲਸ ਨੂੰ ਹੱਲ ਕੀਤਾ ਹੈ। ਆਓ ਹੁਣ ਇਸ ਦੇ ਆਧਾਰਿਤ ਕੁਝ ਹੋਰ ਐਗਜ਼ਾਮਪਲਸ ਨੂੰ ਹੱਲ ਕਰੀਏ।
Now let's see an example. Two cards are drawn at random from a pack of 52 cards. What is the probability that both the drawn cards are aces? ਭਾਵ ਜੇਕਰ 52 ਕਾਰਡਾਂ ਵਿੱਚੋਂ 2 ਕਾਰਡ ਕੱਢੇ ਜਾਂਦੇ ਹਨ ਤਾਂ ਇਸ ਦੀ ਕੀ ਪ੍ਰੋਬੇਬਿਲਿਟੀ ਹੈ ਕਿ ਕੱਢੇ ਗਏ ਦੋਵੇਂ ਕਾਰਡਸ ਏਸਿਸ ਹੋਣ। ਨਾਓ ਇਟਸ ਸੋਲੂਸ਼ਨ। ਲੈਟ S be the sample space then n of S, that is number of ways of selecting two cards out of 52 cards that is equal to 52 C2, which is equal to 52 factorial upon 2 factorial into 52 minus 2 factorial, that is equal to 52 factorial upon 2 factorial into 50 factorial, that can be written as it is equal to 52 into 51 into 50 factorial upon 2 factorial into 50 factorial. Now on solving, it is equal to 52 into 51 upon 2 into 1, that is 52 into 51 upon 2 into 1 on solving. It is equal to 26 into 51 equal to 1326. Let E is the event that both the cards drawn are aces, then n of E is equal to number of ways of drawing two aces card out of 4 aces card, that is equal to 4 C2 equal to 4 factorial upon 2 factorial into 4 minus 2 factorial is equal to 4 factorial upon 2 factorial into 2 factorial, that can be written as it is equal to 4 into 3 into 2 factorial upon 2 factorial into 2 factorial. On solving, it is equal to 4 into 3 upon 2 factorial is equal to 4 into 3 upon 2 into 1. Further, on solving, further equal to 2 into 3, that is equal to 6 ways. Thus, the total number of outcomes n of s is equal to 1326 and number of outcomes favorable to the event that is n of e is equal to 6. Therefore, probability of occurring of event E, that is P of E, is equal to number of outcomes favorable to event E upon total number of possible outcomes equal to n of e upon n of s, that is equal to 6 upon 1326. On solving, that is equal to 3 upon 663. On solving, it is equal to
1 by 221.
Therefore, for the given example, probability of drawing 2 aces cards out of 52 cards is equal to 3 upon 663. On solving, it is equal to
1 by 221.
जो कि ਅਸੀਂ ਪਤਾ ਕਰਨਾ ਸੀ। ਇਸ ਐਪੀਸੋਡ ਵਿੱਚ ਤੁਸੀਂ ਸਿੱਖਿਆ ਹੈ an experiment whose outcome cannot be predicted or determined in advance is called a random experiment. Sample space is the set of all possible outcomes in a random experiment is generally denoted by capital S. Every subset of a sample space is called an event. An event may be simple, compound, sure or impossible. Two events A and B are called mutually exclusive if occurrence of an event excludes the occurrence of the other event. A set of events is said to be exhaustive if one of them necessarily occurs every time the experiment is performed. According to the classical approach, if there are n equally likely outcomes of an experiment and m of them are favorable to the event A, then the probability of happening A is m by n. Axiomatic approach builds up the probability theory from a number of assumptions. Addition theorem of probability states that if A and B are two events of the sample space S, then P of A union B equal to P of A plus P of B minus P of A intersection B. If A and B are mutually exclusive events, then P of A union B is equal to P of A plus P of B. Multiplication theorem of probability states that if A and B are two independent events, then P of A intersection B is equal to P of A into P of B.
ਇਸ ਐਪੀਸੋਡ ਵਿੱਚ ਤੁਸੀਂ ਪ੍ਰੋਬੇਬਿਲਿਟੀ ਦੀਆਂ ਕੁਝ ਯੂਜ਼ਫੁਲ ਟਰਮਸ, ਰੈਂਡਮ ਐਕਸਪੈਰੀਮੈਂਟ, ਸੈਂਪਲ ਸਪੇਸ, ਇਵੈਂਟ, ਐਕਸੀਓਮੈਟਿਕ ਅਤੇ ਕਲਾਸੀਕਲ ਅਪਰੋਚ ਟੂ ਪ੍ਰੋਬੇਬਿਲਿਟੀ ਅਤੇ ਥਿਓਰਮਸ ਔਨ ਪ੍ਰੋਬੇਬਿਲਿਟੀ ਬਾਰੇ ਜਾਣਿਆ ਹੈ। ਉਮੀਦ ਕਰਦਾ ਹਾਂ ਤੁਹਾਨੂੰ ਐਪੀਸੋਡ ਪੂਰੀ ਤਰ੍ਹਾਂ ਸਮਝ ਆ ਗਿਆ ਹੋਵੇਗਾ। ਧੰਨਵਾਦ।